Section 2.10 is change expressed as a percent. I can find percent change. Big ideas here. When the original amount and how much it's changed is known, a percent change can be found. Relative error is the ratio of the absolute value of the difference of a measured or estimated value and an actual value compared to the actual value. If a new amount is greater than the original amount, the percent change is called a percent increase. And if the new amount is less than the original amount, the percent change is called a percent decrease. If we look at the take note on page 144, it tells us that. It tells us percent change is the ratio of the amount of change in the original to the original amount. So it's going to be the amount of increase or decrease divided by the original. So it also shows us that we could take the, for amount of increase, new amount minus original amount, or decrease, original amount minus new amount. It doesn't really matter here, guys. We're just finding the amount of increase or decrease. So if we always take bigger minus smaller, that'll give us our positive amount, and then divide by original. And then if we went from something smaller to bigger, it's an increase. If we went from something bigger to something smaller, it's a decrease. So we can label it based off what our numbers did, but we can always take bigger minus smaller, as long as we divide by that original, where we started. In example 1, a coat is on sale. The original price of the coat is $82. The sale price is $74.50. What is the discount expressed as a percent change? Round to the nearest percent. So again here, for my percent change, I'm going to take my amount of change divided by my original amount. And remember, because I started at 82 and went down to 74, my amount of change here is going to be a decrease. So to find my amount of change, I'm going to take bigger minus smaller, divide by my original, and the original price here is the 82. Subtract first. And that gives me 7.5. Then when I divide by 82, I get approximately 0.09146. Keep in mind, we want to round to the nearest percent. And right now I have it in terms of decimals. I need to switch that to be a percent. So I move it 2 places or multiply by 100. I get 9.146%. To the nearest percent, we look at the 1, first digit after where we're trying to round to. 1 rounds down. So here it's about a 9% decrease. It's a discount of 9%, so it's a 9% decrease. Now, the average precipitation for Chicago, Illinois peaks in June at 4.1 inches. The average monthly precipitation in December is 2.8 inches. What is the percent decrease from June to December? So from June tells me that's where I begin, and I go to December. So June is going to be my original. So percent change is our change, our amount of change, divided by original. My change, I'm going to take bigger minus smaller. And again, we said June is our original, and in June it's 4.1. Subtract first, which gives me 1.3 divided by 4.1, which is about 0.31707. Now, I'm going to switch that from a decimal to a percent. by moving it 2 decimal places or multiplying by 100. And here we're going to round to the nearest percent again. So I look at that 7, which rounds up to 32%. So 32% decrease. A store buys an electric guitar for $295. The store then marks up the price of the guitar to $340. What is the markup expressed as a percent change? So again here, my percent change is going to be the amount of change divided by my original amount. My change here, I'm going to take bigger minus smaller, divide by my original. And the store originally buys it for $295. Then mark it up. So the original cost is that $295. Okay, here we subtract first, and then we'll divide. It's going to be approximately 0.15254. We're going to switch it from a decimal to a percent because we want it expressed as a percent change. So 2 places or multiply by 100. I get 15.254. Here we're going to round to the nearest percent again. So I look at my first decimal after what I'm looking for. 2 rounds down. So 15%. It's a mark up. I went from a smaller number to a bigger number. So this is an increase. About a 15% increase. Now, in 1 year, the toll for passenger cars to use the tunnel rose from $3 to $3.50. What was the percent increase? So for percent change, I'm going to have P% equals my change divided by original, or where I started. Here, I am going to take bigger minus smaller to get my change. And I look, where did it start? Okay, well it rose. So I started at 3 and then went up to 350. So 3 is my original. Subtract first and do these in 2 different steps. Otherwise, make sure you put this in as parentheses. Okay, otherwise do it in 2 different steps. Subtract first and then divide. Here I get approximately 0.16666 repeating, okay? We want to write this as a percent increase. So I move it 2 decimal places or multiply by 100. I get 16.66 repeating. We round up because 6 is bigger than 5. And so it's about 17%. And that is an increase because it went up. We can use percents to compare estimated or measured values to actual or exact values. So the take note on page 146 at the top talks about relative error. Relative error is the ratio of the absolute value of the difference of the measured or estimated value and an actual value compared to the actual value. When relative error is expressed as a percent, it is called percent error. So here, guys, this whole absolute value of the difference of a measured or estimated value and the actual value, we're still just taking bigger minus smaller. Okay, we're still just taking bigger minus smaller. It's our change. We always compare it to the actual, which is like our original. It actually is this. It started off as that. We just guessed it after the fact to be something else. We estimated it. So we're going to take our change divided by actual here, just like we did with percent change. A decorator estimates that a rectangular rug is 5 feet by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? So here we're talking about area. So we need to figure out what our 2 areas are. the estimate versus the actual. So we find the area of a rectangle by taking length times width. So here it says it's 5 by 8 or 40 square feet for our estimate, but actually it's 4 by 8, which is 32 square feet. Okay, now as far as finding our percent change goes, I'm still going to take bigger minus smaller. And again, this is of my areas because we're talking about area. So my areas are 40 and 32. And I divide by the original, which is the actual. Because that rug was actually 4 by 8 way before we ever said, maybe it's 5 by 8. Okay, that's where it started. That's its real amount and what it originally was before anybody ever estimated it to be 40 feet squared. We subtract here and get 8 over 32. When we divide, that's 0.25. So we're going to write this as a percent error. So again, I'm going to move my decimal 2 places or multiply by 100, either way, which gets rid of my percent sign. So P is going to be 25%. Now, you think that the distance between your house and a friend's house is 5.5 miles, but the actual distance is 4.75 miles. What's the percent error in your estimation? So, percent error is going to be the change in our estimated and actual divided by actual or original, which again is how much it originally was before we guessed. So my change here between 5.5 miles, and here I'm just talking about my distance. So I don't have to do anything with like area. We had to calculate our areas. Here we're just talking about distances, and they give us those distances. So it all depends on what it's asking you to find. There's my change. My original is the actual amount. Okay, it was originally 4.75 miles way before we ever guesstimated it. Subtract first and then divide, which is going to give me approximately here 0.15789. Okay, we want this as a percent. So to get rid of my percent, I'm going to multiply by 100 or just move my decimal 2 places. So P is going to be about 15.789%. To the nearest percent, I'm going to take that 7, which is bigger than 5, and round up. And so I'm going to have a 16% error. And I will continue section 2.10 in another video.